My name's Mike Wareman. I teach the Lego-Robotics camp here at Olds College. We've been doing this for a number of years. I've started way back when it was not as robotic as it is or free form now. I guess for me the goal is that the kids have fun, learn a little bit about building, learn a little bit about programming. Of course, this is being used in high schools and even at university level for teaching just basic math and engineering skills. So, if we're trying to teach, say, a math class, we can say how many rotations would this robot need to make to get, say, cover a 5-meter distance. So what we need to know is the circumference of this wheel, and then because there's gearing, every time this big gear turns once, this little gear, I believe, will turn 4 times. Lego software comes with the kits. It is based on the LabVIEW software that they use for programming thermostats, and all sorts of different things are used.
I'm Griffin Andrews. I go to Three Hills School. I'm 12 years old and I'm going into grade 7. We're here to learn how to do robotics with Lego. We've been building different robots and putting them to work, like this Jagster. We've been racing, then we built another bot just to learn how they work. To learn is actually doing it, not just being told. And like this, he just taught us how to do this, then he just let us build, then program it. This is where we plug our computer, and we plug the NXT into the computer to give it directions and for the sensors to work. The challenging part is sometimes building it. If it's really big, it's more challenging, but if it's just a small, simple build, it's easier.
You've set it to B and C, which are the B and C on here, right? And you've chosen a directions, right? So click on the motor block, right? And so you've chosen which direction. You can set the steering, which is what you've done here, right? So you've set it to steer. What's this?
This is the ultrasound. This is the thing on the front. It just sends sound to the wall, and it, like I have it here, set onto 50 inches, and it sees it, then it turns until it finds a clear space.
What we've done is, this is the start of the program, this is the end. We've created a continuous loop so that when we start, the first thing the program is told to do is start motors B and C and just start driving. We have an ultrasonic sensor that is waiting to see if it sees something less than 50 centimeters in front of it. If it does, then it's told to stop the motors, change their direction, and then turn them a little bit. And the way we achieve the turn is one wheel turns more than the other, and so then the robot will turn on the spot. If, on the other hand, the ultrasonic does not see anything in front of it less than 50 inches away, then it does nothing and it just keeps driving forward. Once we've done our turn, we come out, the loop tells us to come back to the beginning and start over, and it will just repeat that over and over and over again.
This is the sensor we use. Mine, I put it up here. Some people put it back here. It sends sonic to the object in front of it, then it bounces back. It gets set how many feet it should be before the object before turning around. Like this is, say, 50 feet, then it should see the object, turn around, then go the other way. If it sees another object, it just keeps turning until it finds a clear path. Clear path, so it just keeps turning until it finally finds one. Yeah.
Okay, so this is our vehicle called the Devastator. It has spikes on the back, it's got spikes on the side, and then when these front wheels are spinning, it's got spikes on the front. For when the tires fall off, these extra wheels in here keep it going for quite a while. It doesn't stay straight, but it's impact resistant, and that's all I really have to say.